All right, welcome back, everybody. Today we're going to dive in a little bit of setting up our molecular. We can also look at the count file a little bit using an online tool called iDEP. But here in front we have the SRA run selector. So this is going to help us rename our counts file. Down here we have the reads that we used. So we used 70, 71, 74, 75, 78, 9, 80, 81, 86 through 89, 86, 87, 88, and 89. And what we're going to rename them, that way these tools are able to understand kind of the replicates that we're using. We're going to name it something like P53 minus and then mock, or the control, or P53 positive and irradiated. So we can jump into Excel and kind of see the raw output from the counts, feature counts that we did last time. So at the top here is just a header that's put in by feature counts to kind of give some information of what was used to get the information below. We don't need that, so what we can go ahead and do is delete that. And then on the right hand side here we have our gene ID, or this is like the accession number of that feature that was counted by feature counts. That is important, but all of this here for what we're going to do is not important. So what we can go ahead and do is remove those columns. So now we're left here with our 12 columns, which are going to be then matched up with what we had on our SRA selector. So like for instance, this one here is SRR 2121 770. If we go back over to Firefox, we can see 770 was P53 minus, or knockout, and then it was the control, so there was no irradiation. So in Excel, we can go here, we can call it something like P53 positive or minus, and then mock. And then we know that the next one was the same thing. And we can rename all of them based on that. Give me a sec here. I have them copied in another one. All right. And then we can go ahead and save this. So now we have our treatments. So this is a treatment, this is a treatment, the next four are a treatment, and then these four are also a treatment. So we have it saved. We can go back over into Firefox. We're up here. So this is iDEP, and it's a web application that we can use that was written by a former professor of mine to look at our read counts. To do that, we can just browse read count text. So then it's going to go through and it's going to upload it. Once it's done uploading, it's going to do a little bit of pre-processing. You can't see my mouse. There we go. It's going to do a little bit of pre-processing. And then when it's done, it's going to give us a table of what that looks like. So here we go. We have our mock and then mock 1. So it knows that these two are from the same treatment. And then this mock 1 is just a replicate of mock. And then if we go to pre-process, we can see it gives us some really cool pictures. We'll do this in R as well, but like up here, it distributed the colors based on the treatments that it thinks that it has. Down here, we can already see that our treatments are pretty good. We want a really high correlation between what would be replication 1 and replication 2. This means that the count of rep 1 and rep 2 are relatively close together if we have what would be a 45-degree angle if this was square. If we look at something like 53 mock, and then we're going to go, so let's knockout mock. If we look at non-knockout and then irradiated, we can see that that drops down. So our correlation now isn't as good because we're looking at two different treatments, which then should later on lead to some differentially expressed genes that we can further investigate. But there's a lot of tools on here. You can go through and play around a little bit. You can see here that it clusters them pretty good. It has all of them split up based on the different treatment. So that means that our reps of a particular treatment are closer to each other than they are to another one, like we had seen on the previous log plot. You can do k-means clustering, so you can have 4 clusters, and then all of the genes. And sometimes it takes a little bit to calculate, but in here there's tons of different tools. So we can see that inside iDEP there are a lot of really useful depictions of our data that give us an idea of whether or not we can see some kind of trend already between different replicates or the different groupings that should hopefully lead on to make our analysis a little worthwhile. If we had seen some of these baby blue thrown in over here with the purple, it could make it really hard later on to see differences between the 2 particular groups. And especially in this case, when we want to look at whether or not the irradiated mice are different than the mock mice, it would give us an answer later on whether or not irradiating the mice is actually causing anything, whether there's some pathway being activated or however that goes. But like here in the PCA, we can see that our untreated mice are relatively close together, clustering close together. And the only difference between these are whether or not they have the p53 knockout or if they're just a control mice. But yeah, so if you guys want to explore this, feel free. There's a lot of really interesting stuff here. We can do all of this in R2, which is kind of where we're gonna go now. So to set up R, in here, this is a new R session. Up here on the right or on the left-hand corner, you can see a box with a plus. If we click that, we open up this new project wizard, and we can start or set a directory in which we want to start working. So we'll select a new directory. So we'll put it in the p53 folder that we've been working in, and we want to set up a new project. And to do that, we can give that a name, something p53 mouse, and then go ahead and create that project. We can give it a bit, and then we're starting fresh here with a brand new empty project. And something that I always start with now that we have a new project is going to be a new markdown document. The new markdown document, we can give it a name, so you can put your name in here, the title, mouse, we'll call it the same thing, p53 mouse. And then HTML, so it'll be like something that opens it in Firefox or Google Chrome, PDF, some output. We can always change it later too, but then we click OK. Now we have our kind of working document. We can go ahead and delete all of this stuff. And then here we can give it, so these pound or hashtags, if you will, kind of give you an idea of the heading. So 1 would be like the biggest, all the way down. I think there's 3 or 4 levels before there's no really, or not really any more in between. If we do 1, we can do our project. Cool. So in order to put in a code line, we have to do the same that's in the tilde key. Do 3 of those on 2 different lines, and then inside we put down what kind of a code we want. And there's like a handful of different ones, so we can run Python in here, we can run R, we can do Bash. If we were on Linux, we could run Bash from within here, but we're just going to do R. And so the first thing that we have to do now that we're in this brand new project is install some packages. And in order to install packages, we have to do packages from 2 different locations. So we can do the typical one, which we can run with install packages, just like that. Or we can do install packages this way. So we can click install, and then we can go whatever package you want to call. So the first one that we'd have to install is BiocManager, and that it's going to allow us to do some of the more pathway analysis stuff down the line. So we can click install, and it's already installed on here, so maybe it'll update it. Nope, I got an error for some reason. That's okay. But it's already installed, so we should be able to keep going. But if we do install packages, some of the ones that we have to install here are going to be that BioManager, so we can create a heading. Installing packages. And we'll throw this in here. So you have to install bio. Ooh, that's really hard to see. Installing packages, BioManager, dplyr, gplots. So we're going to be able to do some the same heat map using gplots, ggplot2. So that's going to give us some of the prettier point plots, and then ggrepel. So then down here, to install them, we could do each one independently, dplyr, and quotes, dplyr, or we can do them all together. So C and R means concatenate, and then inside here we can just keep listing them. So then we can do gplots, and then ggplot2, and then ggrepel. So now if we run this by Control Enter, probably going to get a couple errors down here too. I'm not sure exactly why. My R version is probably old too, but so it looks like it actually installed them all. And then we have some messages here. That's kind of annoying, but we'll close that. So now we should have all of these installed. Now if we want to install packages with the BioManager like we were talking about before, we have to do the 3 lines again. We want to run R code in here, and then we can do BioManager install, and then list them all in here the same way, kind of like we had done above. We can do C again. We're going to concatenate a bunch of them together. The nice thing in R2 is if you highlight, so say we don't have these here. If we highlight this and then we do Shift and then 9 in order to put in a parenthesis, it'll automatically put a parenthesis around whatever was highlighted. So here we have to install a bunch of them actually. So I'm just going to copy and paste what I had listed, written out before. So copy, paste. So we have to do limma. That's going to be kind of a differentially expressed gene package. There's also edge-R, which we sell on the website for iDEP. dseq2 is another one. AnnotationDbi is going to allow us to, I believe, compare the annotation that we have to map our annotation, like our gene IDs, to different ones that are going to be found in musculus. So this is going to have all of the different combinations. Bunch of other ones in here, but the important thing is to install them. I'm not going to run it since I already have everything, and it takes a while, but when that's done, then you'll have a similar output as to what you had when you ran the install packages. We can make another heading. We can say something like importing, oh, this is going to be a header. Import data counts. And if we click this little tab up here, it gives us a really nice layout of everything that we have laid out. So import counts file, and we can do our 3 lines. We want to run R code. Another thing up here we can do is give it a name. So this is chunk 4, you see, we can call it importing counts, and it'll change that name. Later on, when we have, if you want to knit this document, it'll say like chunk error or error in whatever lines, and it can help you find where your errors are coming from. But we will not do that. So we installed our libraries up here. Now, in order to load them, so they're installed on the machine, but they're not actually in the environment that we're working on. In order to do that, we have to do library, and then we can pull up whatever we want to load in. So a big one is going to be the dseq2. We'll also do dplyr, and right now that should be good. We can call counts, we can call count data, read.csv, and that's going to let us pull in the CSV document that was our read counts, and the folder over here on this drive, there's a folder called p53melis that we put in. So I just moved the read counts file that was saved when we edited it into this folder. So now we should just be able, since our project is here, we should just be able to say read counts.csv. And then we might have to say header equals 1. So it knows that our header is column. So if we look here, we can see we have our by saying header equals 1, we're telling it that the first row in our file is actually a header. So we don't want it to think that this is another gene, and gene ID is something that it can try to map. We want these to be column names, and then later on we can pull from them. So we can see that now our count data is exactly what we were working with before, which is really good. That should do it for today. Just going to be a short, quick one. I know it's been a while since I had up another one, but I've been really busy with work. So I'll try to keep, maybe in the next week, put up another one further analyzing. I can show you kind of what I'm going off of. If you guys want to go ahead and try doing more on your own, this is essentially what I'm going off of on my GitHub. It's exactly what we had done for the course. Later on, we'll go on to a little bit different things. Right now for work, I'm trying to do some splice correlation, figuring out what groups or what cancer patient responses correlate to a particular splicing variation of gene. So later on we can talk a little about that too. But if you want to read through some of this and explore on your own, feel free to do so. I named them a little bit different here, gave them actual names, but there's some more explanation on here as well. So something that I could quickly mention, if we go back to R, here we go, is that, so this is called Markdown, and you can look up R Markdown explanation to find out what all of this is actually doing. But the nice thing about creating a project versus just having a document with just a random R document that has a ton of different tabs up here that are from different projects is that it keeps everything really organized. And also, if you take, you can see here, P53 is the folder name that all of this is in. If you zip the P53 folder and everything inside, and you say, I don't know, give it to somebody else for them to look at, or upload the whole zip to GitHub, barring there isn't a massive file size, somebody can then download that same folder and then double click here on the project file inside of that folder once they extract everything, and they'll be able to do exactly the same thing that you are, as long as they have all of these installed. So it keeps everything really, really clean. And so like read counts.csv, if somebody else had the same file, would still open up read counts file. Whereas if it wasn't in a project, you'd have to then change the mapping of wherever that file is. So if it's on, I don't know, your flash drive or something like that, somebody would have to then say something like D:// read files. They would have to give the whole path to wherever their file is at. And in this case, since it's in the project, we have the P53 mouse project, everything is together. So that's something that I've found really handy when giving other people kind of example projects to work with. Then they can see everything together. So yeah, I'll try to post another one later this week, but see you later.